Okay, so gravity. We're going to do a deep dive today on gravity. Not just like what it are,
right,
but how it shapes everything around us, from, like our daily lives to the hugeness of the universe and
mind-boggling scale of it all.
Yeah, we've got excerpts from a text that goes deep on this, and we're going to pull out the coolest stuff, I think.
Let's do it.
Ready to uncover the hidden influence of gravity.
Absolutely. I think it's one of those things we take for granted,
Totally.
because it's always there.
Yeah.
So to really dive in and think about it, I think will be fascinating.
Yeah, so let's start with like the classics.
Okay.
Newton versus Einstein, like a gravity showdown.
Oh, yeah.
So Newton's whole idea was like anything with mass like pulls on everything else with mass.
Right.
So the bigger the object, the stronger the pull.
Exactly.
It's like magnets, but like for all matter.
A very simple concept, but powerful.
Yeah.
And it kind of held for a long time, but then came Einstein and kind of blew everything up with his theory of relativity.
Yeah.
And he said, gravity, it's not really a force the way we think about it. It's actually a warping of space-time.
So if gravity is like a warp in space-time, does that mean it affects like time itself?
It does.
Wow.
The more massive an object, the more it warps space-time, and the slower time actually runs in the vicinity of that object.
That's crazy.
Yeah, and this has been experimentally verified. It's mind-blowing.
So like to try to wrap my head around this, I always think of that analogy, the bowling ball and the trampoline.
Yeah.
So like the bowling ball is the massive object creating a dip in the trampoline, which is like
space-time.
Yeah.
Yeah, no, that's a great way to visualize it. And that's really what allows us to understand things like black holes.
Okay.
The Big Bang, the expansion of the universe, it's a completely different way.
Yeah. So Einstein really kind of opened up a whole new universe of questions and possibilities.
Absolutely.
Speaking of which, let's zoom back down to Earth.
Okay.
For a second. We all know gravity keeps us grounded.
Keeps us grounded. Yeah, literally. Without it, we'd just be floating around.
Yeah.
And it's also the reason why the Earth is a sphere.
Oh, okay.
That inward pull acts equally in all directions, so it shapes our planet into a ball.
Right.
Rather than, say, a cube.
Makes sense. And we can't forget the tides.
Oh, the tides, yeah.
That's the moon's gravity.
Okay.
Tugging on Earth's water.
Yeah.
It's amazing how one celestial body can have such a force on another one from so far away.
It really is. And it's a constant dance between the Earth and the moon, back and forth. And, perhaps even more importantly, keeps our atmosphere from drifting off into space.
Oh, right.
No atmosphere. No life as we know it.
That's a pretty crucial role for gravity to play.
Yeah.
Okay, so now I'm really excited to get into gravity in space.
Okay, yeah.
Because I feel like this is where things get really weird.
Things get really interesting.
It's like a cosmic ballet with planets orbiting stars, moons around planets.
All right.
And it's all choreographed by gravity.
Yeah, it's this beautiful, intricate dance, and it all goes back to, those warps in space-time.
Right.
So objects in space are essentially just following the curves created by the gravity of larger objects.
Okay, so then you have black holes.
Yeah.
Which are like the ultimate gravity superstars.
Well, ultimate, yeah.
Can you tell us a bit more about those?
Yeah, so imagine taking all the mass of a star and compressing it down into an incredibly tiny point.
Whoa.
That's a black hole. And that creates such a steep warp in space-time that anything that gets too close falls in and can never escape.
Not even light.
Not even light.
That's terrifying.
It is pretty terrifying.
So like, remember that bowling ball on the trampoline analogy?
Yeah.
A black hole is like squeezing that bowling ball into something the size of a pinhead, and nothing could climb back out.
Yeah, it's a one-way trip.
Wow. Okay, so gravity is responsible for forming all this incredible stuff in the first place, right?
It is.
Stars, planets, everything.
Yeah, they all start from these massive clouds of gas and dust. And over millions of years, gravity pulls those particles together.
Okay.
And they clump, they get bigger and bigger, eventually forming stars and planets.
That's so cool.
It's mind-boggling to think about the scales that this force operates on.
Yeah, it is mind-blowing to think about.
Yeah.
But gravity isn't just out there, shaping galaxies and stars.
Yeah.
It's working right here in our everyday lives, too.
Absolutely. It is everywhere. I mean, think about it. Everything we do, from walking to driving to even just sitting in a chair, it's all affected by gravity.
It's true.
Engineers take it into account when they're designing bridges, airplanes, even roller coasters.
Yeah, I never even thought about how gravity affects driving until I saw a documentary about how roads are banked on curves.
Oh, yeah.
To counteract that centrifugal force.
It's fascinating.
It's amazing how we're constantly interacting with all these forces.
Yeah.
Without even realizing it.
Totally.
And also the impact on our bodies.
Oh, yeah, absolutely.
The text we have mentions astronauts.
Right.
In microgravity.
Yeah.
Experiencing bone and muscle loss.
Right, because their bodies aren't working against that constant pull.
Really makes you appreciate the earthly pull a bit more.
Yeah, it puts things in perspective for sure.
So as much as we've learned about gravity, there are still mysteries to unravel.
Yeah, absolutely.
It turns out that at really tiny scales, like the world of atoms and particles, gravity is actually much weaker.
Yeah, it's true.
Than the other forces.
Yeah, like electromagnetism.
Wow.
So scientists are still working on a theory of quantum gravity.
Okay.
To try and bridge that gap.
Between the very large and the very small. So there's still so much to learn about gravity.
Absolutely.
Even after centuries of research.
Yeah.
That's kind of inspiring.
It is.
It really makes you realize that there's always something new to discover about the universe.
Absolutely.
So who knows what kind of amazing applications we might find for gravity in the future.
Yeah. The possibilities are kind of endless when you start to think about it.
Yeah. So next time you feel gravity holding you down, just remember that it's also the force that's holding our entire universe together.
That's a good way to think about it.
Pretty amazing, right?
Yeah, pretty amazing is an understatement.
Yeah.
I mean, what if we could manipulate gravity?
Whoa.
Think about the possibilities. Traveling to distant stars, building structures that defy gravity.
That would be incredible.
It's a pretty tantalizing thought.
Yeah.
And who knows, maybe one day it won't just be science fiction.
That's a great point. That's it for our deep dive on gravity. We'll see you next time.
See ya.